This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
Hello, welcome to another episode of Design Safe Radio. I'm your host, Dan Zahner, and here with me today, we've got Andre Barbosa from Oregon State University, although this week he is down in what normally would be sunny San Diego, but we're just talking before we got started about the atmospheric river that has dumped, what was it, like 14 inches of rain in 2 days?
Yeah, here in Southern California. It was pretty impressive.
Phew. Yeah, it's quite amazing the amount of water that you can get dumped in just a short amount of time, and it really puts into perspective a lot of the reasons why the NHERI network exists and why we do what we do, although you're working on more seismic resilience than atmospheric resilience.
Yeah, but worried about sustainability, for sure.
Yeah, exactly. So really looking forward to talking about some of your projects, but give us a 60, 90 second intro, and then we'll get into what you're doing down in Southern California.
Sure. So Andre Barbosa, I'm a structural engineer. I've been at Oregon State University for about 12 years, and I had done my PhD actually here at UC San Diego. So it was nice to come back and now work on this project here on the site. But yeah, I've been looking at different products, reinforced concrete, of course, also mass timber, which brings us today to this conversation. And I was fortunate enough that when I joined Oregon State University, it was really the boom. This is like early 2012, where there was a lot of interest, growing interest in the Pacific Northwest to start looking further at mass timber. And yeah, it's been an amazing ride. There's a lot of work, there's a lot of interest, there's a lot of need. That is also tied to climate change, but really also tied to these opportunities for creating more rural jobs, workforce development, tying both sides of the equation to create sustainable, but also, job opportunities in our Pacific Northwest.
Yeah, I was just talking to an architect yesterday about a mass timber project going on here in Eugene for they just changed some of the local regulations about building auxiliary domestic units. I think that's what ADU stands for, but
ADUs,
small houses in your backyard so you can rent out, right? And there's a huge interest in doing mass timber for that, because you can get most of your building prefabricated. The site construction is a whole lot quicker than a stick-built house, and obviously you've got the sustainability aspect there too. And it's just really cool to see that finally starting to gain a little bit of momentum on the residential front, at least here in Eugene. It's
right, as well. Mm-hmm.
Yeah,
and provide alternatives for people.
Yeah, absolutely. So your project, the NHERI Converging Design, is kind of the envelope for your project. Talk about maximizing functional recovery and integrating those sustainable building design principles we started talking about. Can you kind of unpack that, what that means for people like earthquake engineers and our friends, the architects, and we'll go from there.
Yeah, so those two words, converging design, are really because we are trying to bring these two relatively new ideas. Of course, there's a lot of work on them separately, but now bringing them together and converging into one design methodology. So on the functional recovery side, maybe just explain a little bit that deals mainly with coming up with a new design paradigm, not only around earthquakes, but we're focusing on earthquakes here. And in a nutshell, our codes today, our codes and standards are written really for life safety. That is written so engineers can produce building designs that enhance life safety. For example, after a big earthquake, right, people should be able to evacuate buildings without harm and safely. So no loss of life, that's really the goal. But what's been happening is that after these major earthquakes, then buildings sometimes have to have very expensive repairs, long repair times. People can't go back to their houses, can't shelter in place, and many buildings may even have to be demolished after these big earthquakes. So even though, for critical buildings, we had already thought about functional functionality, making sure hospitals were functional, making sure schools were functional. Really, our building design codes are that's not how they are written today.
Right.
But our society is not too happy about that as we get more of these big events. There's this idea, and folks do, their households and businesses should be able to recover quickly after these big major earthquakes. And so functional recovery, which is these two complicated words put together, is really trying to envision codes, and but not only the we is the big we engineering community, both researchers and practicing engineers, are starting to think, how do we write code so we still achieve safety and life safety, but we can start having building designs where we have more acceptable recovery times, where really, can we have post-earthquake reoccupancy, and can we minimize the recovery time so that businesses and people can get back?
Right.
So that's a long-winded answer maybe for your question, Dan, but functional recovery. That's one aspect. The other aspect is sustainability, right? And sustainable building design principles. So what we're looking at is looking at materials that reduce environmental impacts. And that's, for the same function, if you have two competing materials, which are the materials that reduce, impact on human health, impact on the environment, and that's over their life cycle, right? That's really what we're looking at. With mass timber and with timber in general, but now especially with mass timber, we can start, and mass timber, be it these big glue laminated beams that maybe people are more used to thinking about, or other new engineered wood products, or relatively new engineered wood products like cross laminated timber or mass ply panels. So some of those that are recent and new engineered wood products are now in a way competing, but also providing solutions for slabs, for walls, and for prefabrication. So that's on the sustainability side. That's what we're looking at, is some of those materials and reducing the environmental impact of the materials, but also looking at resilience, the word that you had brought in initially, looking at resilience, looking at, after these big earthquakes, if buildings are more resilient, then they have less damage. If they have less damage, we have less new products, new materials we have to bring in for repairs, or we don't have to demolish and send things to landfill. So we're also exploring resilience as part of sustainability in our side of the coin here. Basically that. There's one more little aspect on sustainability that we're thinking about, which is, what's the end of life of these buildings? Can we reuse some of these elements? And can we come up with design principles that allow us to reuse some of those members after that first design and the building was used for that first main function? As our societies change, and you look at buildings 100 years ago, very different functionally than buildings today. What would they look like in 30, 40, 50 years? So if we are going to adapt our building designs, can we reuse some of those materials? What do we need to do? There's a lot of questions that we don't have answers for, that we're trying to think about in our project.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NHERI Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NHERI Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay resilient.